The next topic is soil profile. You can see the image here. Soil having different layers. The first and the topmost layer is organic layer. It's an uppermost part. It's an uppermost part. It is freshly decomposed, organic matter. It formed by freshly decomposed organic matter, and it is absent in arable land. It is absent in arable land. Arable is nothing but cultivated land. It is absent in a cultivated land. Means where it is present? It is present in forest soil, or we can also say a virgin soil. It is present in forest soil because it is not being used. So this topmost layer is present in forest or the virgin soil. It is absent in arable land. It's uppermost part. Then the next layer is A layer. This is the A layer. This is more darker than these, B and C layer, and it is a topmost mineral layer. Topmost layer is organic layer, but the topmost mineral layer is A layer. It's a topmost mineral layer. And again, in below the A layer there is one more layer, and that is not that important also. This layer is called E layer. Below the A layer there is a E layer, or it is also called as A2 layer. This is what we have already seen the definition of alluviation. So from this layer there is a leaching of sesquic oxide, and this layer is also called as alluvial layer or washing out layer. Washing out. Washing out is nothing but it's a leaching of aluminium, iron or clay. And the next layer is B layer. B layer is below the A and A2 layer. Here alluviation occurs. It is also called a washing in layer. Washing in, and E layer is washing out, but the B layer is washing in, because whatever the mineral leaching that is coming into this layer, that's why it is called as alluviation or washing in layer. Here is we can see the accumulation of iron, aluminium or the clay. And the next layer is it's a C layer. It is also called a substratum, and it is nearer to the rock bed, so it is less affected by the factors, and it is outside the zone of biological activity, because we can see this layer deep into the soil. That's why there is no biological activity in this layer. And here we can see the least weathering. And the next one is bedrock. This is the bottommost layer. Some of the important terms we can remember here is, and these layers A plus B, that is A layer and the B layer, along with the E layer that we have discussed, these three layers are called as solemn. Cumulatively they are called as solemn. A plus B plus C layer, these three layers are called as regolith. You remember this. This can be asked directly. So A plus B layer is called as solemn. A plus B plus C, this is regolith, and this is solemn. ಇದು ಆಲ್ರೆಡಿ ಇದೆಯಲ್ಲ, ನಾನು ಏನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀನಿ ಇದೆಲ್ಲ ಇಲ್ಲಿದೆ. ಯು ಕ್ಯಾನ್ ಗೋ ಥ್ರೂ ಒನ್ಸ್. See, A plus B or A plus C plus B is called as solemn or the true soil. A plus B plus C is called as regolith. It is an unorganized parent material. I hope you understood the topics, that is soil profile. Next we will move to the next topic. Before moving, let us summarize this topic again. And the topmost layer is organic layer. You already know it. The topmost of the topsoil, that is organic layer. This is the elevated layer. It comes first. This is the elevated layer. Then comes is the weathered parent material, then the rock bed. See, O horizon, A horizon, E horizon, B horizon, C horizon. A plus B is called as solemn. A plus B plus C is called as regolith. See, the O horizon is higher mineral soil, occurs commonly in forest soil, that is virgin soil. It's absent in arable or cultivated soil. The A layer is topmost mineral horizon. Topmost layer is O, but the topmost mineral horizon is A. Then the next is E or A2 horizon. It's a maximum elevation zone. Maximum leaching out takes place. It is also called as washing out. Then next is B horizon. It's absent in back soil. Maximum accumulation comes here. It is also called as washing in. Then the next is C. It's a rock or regolith. R is a tide rock. I hope you got the point. Next we will discuss about the physical properties of soil. So there are many physical properties like soil texture, structure, surface area, soil density, soil porosity, soil color, and the soil consistency. These influence the plant growth of plant. These properties influence the growth of plant in terms of root penetration, drainage, aeration, retention of moisture, plant nutrients. This structure, these properties of soil greatly influence the growth of plant. Ultimately, the productivity of plant. So now we will see the first property, that is soil texture. See, you can see this image, and you can make the difference between these two soil by feel. So, soil texture is nothing but it's a relative proportion of particles. What are the particles? Sand, silt, and clay. These are the particles. Texture is nothing but it's a relative proportion of sand, silt, and clay. and it is a basic property. It's a basic property of soil, and it cannot be changed. It cannot be changed by tillage operations or drainage. Anything we cannot change. So soil texture is can't be changed, cannot be changed. There are different sizes of these particles according to USDA and ISCSS, United States Department of Agriculture, and this is Indian Society of Soil Science. Indian Society of Soil Science. You go through on these, the sizes of different soil separates. You can see here the clay having size less than 0.002. This is the diameter of soil. It's in mm, millimeter. The silt having size between 0.002 to 0.02. The fine sand having size between 0.02 to 0.2. The gravel having size between 2 to 20 mm, and the stone having size more than 20 mm. You remember the important soil separate, that is clay, silt. Again there is a differentiation between the sand, that is fine sand, and the coarse sand. Again there is a gravel and the stone. Stone is bigger than the gravel, and you can easily remember because there is a difference of these two and all. You can remove 0 every time so that you can remember like this. The soil textural classes, these are grouped into three main fractions, that is sand, silt, and clay. We have already discussed. These are also called as soil separates. Soil separates. How we can say the soil is sandy soil? If there is a soil, how can we say this soil is sandy soil? If the sand percent is more than 70%, then we can say this soil is sandy soil. If the sand percent is more than or equal to 70%, then only we can say this soil is sandy soil. And the clay separate is 15% or less by weight. Again, we can differentiate this sandy soil into two groups, that is sandy and the loamy sand. Again, these soils is again differentiated into loamy fine sand or loamy very fine sand. Next, we'll see which soil is called silt. In silt, we can see a minimum 80% of silt and the 12% or less clay. The silt group includes soil with at least 80% silt and the 12% or less clay. Naturally, the properties of this group is dominated by those of silt, because 80% is silt. That's why it is dominated by the silt. Only one textural class, silt, is included in this group. Next is clay. If the soil contains minimum 35% of clay, then it is called as clayey soil. Again in clay we can differentiate, that is clay, sandy clay and the silty clay. The next type of soil is loamy soil. It's a mixture. It's a mixture of sand, silt and clay particles. It is clay. It's a mixture of sand, silt and clay particle in any proportion. Loamy soil do not exhibit dominant physical properties of sand, silt and clay because it is mixture of sand, silt and clay. That's why individually it do not exhibit the dominant physical properties of sand, silt, clay individually. The loam does not contain equal percentage of sand, silt and clay. However, it exhibits approximately equal properties of sand, silt and clay. I hope you got the point. You understand this image. It is not important for the exam point of view. See, you can see the numbering here. It's a clay, it's a sand here, and the silt here, and the loam is here. Because loam is mixture. It's a mixture of sand, silt, and clay. That's why it's in the middle. See, clay is, if the clay percentage is more than 35 to 40%, then it is clay. That's why it occupies dominant position here. See, if the sand is like 80 to 90%, then it is called 90, sandy soil. Again here, toward this 100 there is a silt. When the silt proportion is more in the soil, then it is called silty. You can just go through this diagram once. The next property is soil structure. Soil structure is nothing but it's a arrangement. It's an arrangement or the organization. It's an arrangement of particles. It's an arrangement of particles. It can be primary or it can be secondary. See, the arrangement and organization of primary and the secondary particle in the soil is known as soil structure, and it can be changed. It is not like soil, texture. ಇದನ್ನ change ಮಾಡಬಹುದು. It can be changed by by drainage activity or by tillage activity, by application of fertilizers. We can change the soil structure, not the texture. Soil texture is a permanent phenomena and it cannot be changed. It's a basic property of soil. These two are the basic property of soil, but the texture cannot be changed, but the structure of soil can be changed eventually by these activities like flowing, cultivating, draining, liming, application of lime, manuring. We can change the structure. See, there are aggregates in the soil, right? There are aggregates in the soil. Aggregates is nothing but it's an accumulation of soil particle. In aggregate, if the soil aggregate form naturally it is called beds. If the soil aggregate is artificially formed by tillage activity. How means by tillage activity a soil aggregate can be formed? For example, MB flow. If you take the moldboard flow in the field, there is a big aggregate, soil aggregates. That is nothing but we are artificially creating these soil aggregates, and that is called clod. If it is natural, it is called beds. If it is artificial, it is called clod. And again in soil structure, there are different types. We can see the image here. See example of soil structure. Soil can be granular, means it is a grain like, it's like grains, like this. Soil can be platy, it's like flat material, plate kind of thing. Soil can be in a wedge shape, the shape like this is called wedge, you know. Soil can be blocky, even within the blocky there are two types, that is angular, because if the soil aggregates have these sharp angles, then it is angular. If there is an absence of angles, then it can be a subangular like this. Prismatic soil will be having the shape like this. Columnar will be having the shape like this columns. So there are different types of soil structure. Different examples you can see here. Again, we have already discussed what are the granular or the crumb structure. This is the granular, the grain type. These type of soil are commonly found in A horizon. We have already discussed the soil profile. The A horizon is below the O horizon, and the topmost mineral horizon is the A horizon. And these granular type of soil is usually commonly found in this horizon, A horizon. In the prismatic or the columnar structure, we have already seen these two types are the prismatic and columnar structure, and it is found in high clay containing soil, and the mostly found in soil having sodium content. The platy soil, the plate-like structure, commonly found in forest soil of the A horizon. Again, these granular, crumbly and platy are found in A horizon. These granular, crumbly, platy structure found in A horizon. Blocky, subangular, blocky structure, prismatic and columnar structure found in B horizon. This granular, crumbly and the platy, these found in A horizon. The blocky and the prismatic and the columnar, these found in B horizon. You remember this part, this half part is found in A horizon, and this half part is found in B horizon.